So I'm going to go ahead and get this meeting recording. Even though a few of you have already written in the chat, now that it's recording, could you just give me a hi and maybe if you haven't responded, if you're in Indiana or not, where you're at, just so it records that you're participating in class and we have all that documented. So I'm trying out a new microphone system and I hope it works, but adding more equipment only adds more complications. So this is the first time I'm using this microphone to record, and I think the audio will be a little better if it works. So I don't know. So I did a few tests this morning and it sounded okay. Um, there wasn't any feedback. I do have to wear headphones when I use this microphone because then there would be feedback and that would be bad. But I'm hoping because of the recording lectures and people in the future might, or even you in the future might rewatch some of these videos. I think the highest quality we can get is best because often what's going to happen is you're going to refer back to the videos almost like a textbook and skim to the part that you need or that you're interested in. So you probably won't watch the whole video, just certain select things. And, we want to get the highest quality possible. But each year I'm trying to get better at this. So I've tried so many different techniques. I'm also trying, I don't know if you knew how I was writing on the screen, but I have a tablet here and it just works like a mouse. And so I use this tablet here, and I just write using this special pen that works. And I have an iPad, but I found that um, the iPad works better if you're just going to write for yourself, but if you're in a Zoom meeting, I found that the tablet works better and it was considerably cheaper. So I'm kind of disappointed about the iPad thing. But I'm always trying to get these things as good as I can get them, and hopefully one day Ivy Tech Bloomington will just come out with their own podcast studio. And so we can just go in there and record our lectures if we all pull our money together, then we can get some really good stuff. But until then, we're on our own. So I hope you can hear me and I hope the lectures will be okay. Um, but you never know. You never know with internet and weather and all that kind of stuff. Okay. Uh, so I hope the homework is going okay. I looked at grades, they looked like they were fine. I was only asked one question in the past week about like specific a homework question or why something worked the way it did, and that was over scientific notation. So I only got one question for the week, which is good. I mean, it's the first week, so hopefully no news is good news. The only question I got was when you multiply two scientific numbers, why do you then have to change the number again? So that was kind of the question. Um, and I could briefly show that if anyone else is interested. So the question was, hopefully this will work. Okay, I know that Zoom has changed how they do whiteboards in the past 6 months. So the question was something like, what if you had six? Well, that's pretty ugly. 6 times 10 to the third, and then if you multiplied that by 2 times 10 to the fourth, what would that be? So there was some decimals, but I think this example will be good enough if we just look at this example. So 6 times 2 is 12. That's fine. And then 3 plus 4 is 7. The question was, why do you then have to change this number uh, after you get the 12? So why does it have to be 1.2 times 10 to the something. Why is that the correct answer? And it turns out the reason why that's the correct answer is because scientific notation dictates that you can only have one number, 1 through 9, to the left of the decimal place. So this is going to be 1.2 times 10 to the seventh. Well, not to the seventh anymore because we moved this over. So this is now to the eighth. That was the type of question that I can't remember who emailed me, but that was the type of question. And in my in class, we also discussed that as well of why is that the case. So the rule is you can only have one number to the left of the decimal place. So A has to be some number between 1 and 9. So that's the idea. Okay. So it's just there's nothing mathematically that I mean these are equivalent numbers. These are the same number, but it's just the rule with um, it's the rule with scientific notation that you write it in this form. So that's also confusing because it's the same number, so that means it's the right answer. So why is it counting me wrong? Well, that's why, because it's scientific notation. Okay. Um, so what's funny is I don't know on the whiteboard I think I can see your guys' mouse or something. I don't know. Um, I see like little names in different colors uh, darting across the screen. So maybe there's a way of doing like collaborative work on the whiteboard. I'm not sure. I haven't played with that yet. So um, yeah, okay. Good. So in the chat says that I was the one that asked, and that makes sense now. So it's just a rule. It's just a rule of abbreviating. Abbreviating. I guess it's like abbreviating a long, complicated medical word. They only do one letter. So, or almost always you'd only do one letter as opposed to doing many letters. So one letter for each word. So if you had 3 words that you want to abbreviate, you just use 3 letters left of the period in English case. Okay, so that would be the situation there. Okay, that was the only question that I got. If you have any more questions, please send me a message or please send me an email and I'll respond as quickly as I possibly can about that. I anticipate in the future you will have questions and that's normal. So and since we don't meet in person, that's the best time to do it. And often class is so fast paced because we're trying to get as much done in that short amount of time at once that it'll come up. Okay. So never hesitate to send me a message or an email at any time, and then I'll respond when I can. Okay. All right. So if there are no questions, then I'm going to go on today's material. And one thing that I need to mention is that we're going to actually need some numbers from the textbook. Okay, so that's kind of funny. Now I'll tell you when we get to it, I'll tell you what page, and then I have it pulled up um, on a digital copy as well. So you'll have access to a digital copy. If you still don't have the textbook, that's okay. There's a digital copy posted in our class. Maybe I'll just show that right now, and then we'll go into the work. So right here, I have it pulled up because I'm going to need these numbers. But in the modules here, you'll see that you do have access to a digital copy of the textbook. Um, and so what I'm going to need is some of the numbers from the textbook. It has to do with the CPI values. And to be able to answer the questions, I need it. So I need the numbers that are in section 4 when we get to the problems, of course. And I believe in the physical textbook, it's page 42. On this PDF, it looks like it's page 7. Okay, so I'm going to come back to this because I need these values to answer the questions in the highlights from the book, and then you will need these numbers for the homework. Okay, I'll remind you that again, but you definitely need these numbers to answer the homework because you can't have them memorized, of course, but you're going to need these values to be able to answer the homework. So I hope that's clear. It's not something that you can just look up, or it's not something you actually need to refer to from the textbook. And it's either on page 41 or 42 of your textbook, but you have a digital copy even if you don't have the textbook. There it is. It's right there. Okay. Um, yeah. So if that's confusing, let me know. Okay. So I'm trying to make it as clear as I can, but every semester I'll get emails and they'll say, well, I looked up on Google and it I should be right. It's like, well, the homework isn't based off of things you find on Google, it's based off the textbook. So that's the issue. Okay, so I'm going to clear this page. We're going to start fresh here. And hopefully you can see that screen and hopefully you can still hear me. Okay. The first thing we're going to go over is section 4. Okay. And section 4 is going to have to do with a lot of what if problems. And those what if problems are proportions. So we're going to say, what if this state was proportional to this state? So for instance, um, what if Indiana's budget was proportional to Illinois or Ohio? What if it was proportional? Okay. So if their population was the same, but their budget was different. Now, the confusing thing when you look at this for the first time is that we already have all of the information we need. And so that gets confusing because you're looking at it and it might ask you, well, what would Indiana's budget be? And you say, well, I already know what their sales are. It's given to me in the chart. But we're asked, what if Indy was proportional to Muncie? And so we'd figure out what it would be. So we know what it is, but we could figure out what it would be in that case. So that can be a little confusing. So when we go over the example, hopefully that'll be clear to what we're doing. So section 4 solves proportions for what if problems. Problems in this section will solve expected values. Consider the chart of Friday shopping sales by city below. Solve for each expected value. Find the expected number of sales for Indy if it were proportional to Muncie with respect to customers. So what are we solving for? We're solving for Indy if. What if Indy was proportional to Muncie? What if? Then what I'm going to do, since I have a digital copy of the work here, I'm going to put an X over Indy because I'm going to say that's the unknown now. I'm going to say, what if it was something different? What if it was proportional to Muncie? That's what the question is. So proportional to Muncie. So now Muncie is the standard. So what I'm going to do is I'm going to write this over here. I'm going to write Muncie's values right there. So I have 4,012. That's what the chart's telling me. And then I have 32 customers. Okay, that's my Muncie side. Now the Indy side, I'm pretending that I don't know what it is. I'm saying, what would it be if it were proportional to Muncie? So it'd still be 60 customers, but we'd see what those sales would be. Okay. So this is Indy, and then this is my Muncie side. And the reason I am doing Muncie is because they said if it was proportional to Muncie. So I put all the values that I know about Muncie over here, and then I put all the values for Indy on the other side, right? But another confusing thing is there's actually 4 ways to set this up and it be correct. So that can also be confusing. Okay. But hopefully it's clear. Um, Mackenzie asked, is this a page in the textbook? So this is actually kind of just highlights from the textbook since we don't have time to go through the actual textbook. I just stole certain problems to go over, so this isn't an exact page, what I'm looking at right now in the textbook. Okay, but I will post these notes after class. All right, so hopefully that's clear. Just since we have kind of um, a limited time, we don't have full lecture time. I just steal problems from the book and we just kind of look over the more important ones. Let me know if that's okay. But I will post these notes after class. Um, yeah. So my in-class folks, we meet 4 days a week for 75 minutes, and we do go over the book page for page. But even then, I have to skim a little bit, believe it or not. There's still not enough time to go over everything. Um, but here, I just give you the highlights, and for the most part, I think it's okay. Okay, so hopefully, how I set this up, how I chose to set it up, and why I'm setting it up the way I am makes sense. The most questions I've gotten in the past is, well, if you know what the value for Indy is, why are you putting an X there? But they're saying, what if? What if we didn't know Indy? What if it was proportional to Muncie? And this we set it up. Okay, but how do you solve for it? Now that you've actually set it up, how do you solve? So the way you solve is you're going to cross multiply. Okay, that's what you're going to do. And that's what the notes here are saying. So we have 32 times x. So we're going to cross multiply, okay? Crisscross, applesauce. We're going to cross multiply, so 32x. And then we'll have 60 times 4012. And so I believe it's this value, but we can, of course, test that hypothesis. So I believe it'd be 60 times 4012. And yes, that is that value, 240,720. And so now let me do a different color. So we've gone from this step to this step, okay? So we crisscross applesauce, we cross multiply 32 times x, so we have 32 x's equal 240,720. But now we need to divide by 32 because we want to know what x equals, not what 32x equals, right? We don't want 32 of them, we want one. And we want to see what that is. So once we divide, we think it's this value, but we can of course test that. Will my calculator understand what I mean when I say divide? Um, Copy as plain text, sure. Divided by 32, and there we have it. So we have $7,522.50 expected for Indy. So I hope it's clear what I'm setting up. What I'm trying to set up is, what if Indy was proportional to Muncie? So even though we know the exact value, we're seeing what it would be, okay? So that's what we did, all right? But what we find is if it was proportional to Muncie, they would actually have more. They would have more in sales if it was proportional with the amount of customers. So we see that they have more customers, but by proportion, they're making less money. So, yeah. Okay. Find the expected sales for Caramel if it was proportional to Indy with respect to customers. Okay. Expected number for Caramel if. That makes Caramel the what if. That makes Caramel the unknown. Okay, so I'm going to take that away. Caramel is now my what if. So I'm going to put an X there just so I know that's what I'm doing. So caramel is my what if proportional to Indy. So Indy is now the new standard. Indy is now the new standard. So I'll circle that so we know that's what we're looking at. And since I just kind of set them up always the same way, I'm just going to continue. So here I have my Indy values because it says if it was proportional to Indy. So Indy is now the standard that we're comparing to. And what would the sales be? And of course, Carmel had 21 customers. Now, what I can do is I can solve for that X. Okay, now I can solve for that X. How do you solve for that X? You cross multiply. So we need to multiply these two numbers. And then we need to multiply these two numbers. So what is that going to give me? Well, it's going to give me 60 x's equals And then I'm going to ask my calculator what this equals. So 6,812 times 21. And by the way, if you do this on your own calculator and you get something different, please let me know because I make mistakes just as much as anybody else. Okay. Now that's what I think 60x is equal, but of course that's not what we want. We want 1x. So I'm going to divide both sides by 60. Okay, will my calculator understand what I mean by divide by 60? No, it doesn't. No, it's only a calculator. Okay, divide by 60. So I think we would have $2,384.20. Put a little circle around that so we know what we're looking at. That would be the expected sales of caramel if it were proportional to Indy. What do we see? We see that their expected sales would be less. Well, we've tested Indy against Muncie. We find that they would actually get more if they were proportional. We see that if Carmel was proportional to Indy, they would have less. So I think what we're finding is that this Indy location is not doing so well. Even though they have the most customers, they seem to have low sales. So that's of interest. Okay. But I hope it makes sense when I'm setting up the why is this one the X? Why am I setting up the other one with all of the numbers? Like, why did I put an X over this one? So I hope that part is clear. Okay, I'm trying, and if it's not clear, please write that in the chat, and I'll be able to address it. But I'm hoping it makes sense of how I'm able to read this question and then understand. Okay, this is my what if value. What is the expected number of sales for Lawrence if it were proportional to Muncie with respect to customers? Okay, expected number of sales for Lawrence. So Lawrence is the what if proportional to Muncie. So now Muncie is the standard. Okay, so I'm going to take this away. And now Muncie is the standard. Lawrence is the what if. And with respect to customers. So customers stay the same. We're seeing what is the expected number of sales. Expected number of sales. Okay. So X for Lawrence, 50 customers, $4,012, 32 customers. So now I believe I can find what the sales for Lawrence would be if it were proportional to Muncie. All right, let's see what that would be. Now, how do you actually calculate that? We're going to cross multiply. So 50 times 4,012 and 32 times x. Okay, so that gives me 32x equals, and then hopefully this calculator is always so fussy. 4,012 times 50, 200,600. Okay. And I don't want 32 of them. I want one of them. So I'm going to divide both sides by 32. Okay. And so that must mean that x equals this divided by 32. Okay. 6,268.75. So 75 cents there. Okay. that's what I think the expected sales of Lawrence would be if it were proportional to Muncie. And what do we see? We see that even though Lawrence has quite a bit more customers than Muncie, proportional sales, Muncie seems to be doing very well. So for their low customers in comparison to like Indy and Lawrence, it seems proportional that they're making high sales. So there you go. So we see that if Lawrence was proportional to Muncie, it would have much higher sales there, much higher. Okay. So that's the what if portion. This what if it was proportional? Okay. Okay. Now I'm going to ask you, does it make sense of where I'm putting the X? How, when I read the question out loud, does it make sense of how I know what the what if value is, how to set it up? Is that part okay? If anyone's lost over that, please speak up. Trying to, when I explain, I'm trying to think of all the times I've had students not understand it and what they've said. Um, and just want to make it as clear as possible how I know what is the unknown value, because in truth we have all we have all the facts there. We have all the facts there in that table. So there is no unknown. But the question is, what if sales were proportional? And I don't know if you've ever worked in a big box store, but I have. And when you work at a big box store, this seems to come up a lot in the meetings. Well, in this location, they're making this kind of sales, and it seemed to come up a lot. But now, ironically, I'm going over it in a class. But I know that when I worked at a big box store, we would always have comparisons to other locations, and that seemed to come up a lot. So that's what it reminds me of. Okay. All right. So I hope that's clear. Again, I'll be posting these notes after class. Now, this part, another useful application of proportions is for inflation. The Consumer Price Index is a monthly number that reflects changes in the prices for goods and services. This number is not a price, but a marker for the rise and fall of prices. It can be used to make predictions for the future or past prices since it describes what the prices were at the time. Refer to section 4 of the book for the CPI values during the homework. So, yes, we have to refer to the book to get these CPI values. It's not something that will be memorized, okay? So that's something to keep in mind. So we have to keep referring to the book to get those CPI values. Another thing that I'm going to say is we never use the year in our calculation. I'm going to write that down. Never use the year. Just a little note for you. Okay. So never use the year in your calculation, but we have to use that CPI value. Where does the CPI value come from? It's either on page 41 or 42 of your textbook. If you don't have your textbook, there's a digital copy in that module. And that's what I'm going to use since this is a virtual class. I'm going to use a digital copy. Okay, so I'll have to keep flipping back and forth to get those values, but that's the deal. So these are not just derived in any way. I have to refer to the book. Okay, so that's the deal. It'll either be on page 41 or 42 of your book, and I think in the PDF it was page 7, but we'll see when we pull it up. So if the price of oil change is $45, an oil change is $45 in the year 2015, what is the expected price in the year 1985? Okay, so we know the price in 2015. So this is how I'm going to set it up. It's $45 in the year 2015. So I need to look up the CPI value of 2015. Okay. And I'm not going to plug the year in my calculation, but I need to plug in that CPI value. Okay. Now I'm going to solve for the price in 1985. So that's going to make the 1985 value the unknown. And then I need the CPI value for 1985 from the book. Okay. Okay, so I need two values from the book to be able to um, solve this proportion. So what I'm going to do is 45, and then I'll have the CPI for 2015. The unknown is the price in 1985. I'm assuming it's going to be less. And then I need this CPI value for 1985. I will not write the year in my equation. I will not write the year in my equation. I will not write the year in my equation. Okay, the CPI value. All right, 2015 in the book is 237.017. 237.017. Okay. In 1985, 1076. Okay. So did you see where I got those? I'm getting those from the PDF here, but it's also in your textbook, either on page 41 or 42 of the text. Here, this is posted in Module 2, Learning Activities, Section 4. So you have a digital copy. It's the same digital copy I'm looking at right now. And the CPI value for 2015 was 237.017. In 1985 is 107.6. Sounds like a record station or something. But this is the inflation marker. Okay, so as this increases, as this value increases, the worth of the dollar goes down. So it's kind of inverse proportional there. So you can think of the price of things is increasing. That's the way. It corresponds with a year because every year it's tracked, and in fact every month it's tracked. But here you never use the actual year in your calculation. Okay, and you'll never see me do it, and you'll never do it. So don't do it. Okay, here in the book you'll see they use the CPI notation just to let you know you're using the CPI value, but never the year. Never the year. Okay. So I do hope that's clear that I have not plugged in the year in my calculation, and nor would you. Okay. Now we need to solve for that x. So let's do that. Okay. So how do you do that? You cross multiply. Okay. So let's cross multiply. 237.017x equals, okay, and that is 107.6 times $45. So we get 4842 divided by, no, why does it do that? Divided by 237.017, and we get about $20.43. So if an oil change followed inflation perfectly from 2015 all the way back to 2000, or I'm sorry, 1985, then it would have cost $20.43 in 1985. Okay. We expected it to be less. And that's what it would be. Okay. Typically, you go the other way. If something cost this in 1985, what would it cost now? That's typically what you do, or what would we expect it to cost in the future? That kind of thing. So, again, we're using the CPI values in our equation, in our proportions, but we're never using the actual year. Okay. Please, if there's any questions, comments, or concerns, um, don't hesitate to write in the chat about that, okay? What is the price of tuition in the year 2010 if the price was 1,865 for the year 1985? Okay, so what I'm finding here is I need to find the price in 2010 because I have the price in 1995. All right, so let's set that up. So I think it's 1865 CPI 1995. CPI value, not the year, CPI value. The unknown is the price it would be in 2010, and then the CPI for 2010. Okay, now where do I get those CPI values? You get them on page 41 or 42. Write that down for you. So CPI values are coming from page 41 or 42, or that PDF I have uploaded for you. That's another place you get them. And you have to use these values to answer the homework. Okay, so the homework is based off of those values, so you have to use those values, okay? So let's set this up. So I need the CPI value for 2010. I have the price for 1995. And so I need to get those. So 2010 is 218.056. And 1995, 152.4. Okay, so I would expect it's going to be more. I expect it's going to be more. Let's see how much more. So X would equal 218.056 times 1865 over 152.4. Okay, now I need to plug that into my calculator. There we go. Okay. 218.056 times 1865. Divided by 152.4. So we're thinking it's about $2,668.47. And that sounds about right. I was talking to my in-class folks yesterday about inflation prices. And the truth is, um, tuition at Ivy Tech, and I'm not a company man by any stretch, but it actually is pretty close to inflation. So they do seem to follow inflation pretty well. So if you go even back to the 70s, how much college cost to tuition prices now at Ivy Tech, it's pretty close. I mean, it might not be down to the cent, but it's actually pretty close. And I find that with community colleges generally, if you compare it to the area it was, that's pretty close. But if you compare it to like tuition prices at IU, no, IU they've gone off into their own scale. But yeah, so this rings somewhat true to me, and tuition prices do seem to follow inflation, and I think that's probably because they're tied with, uh, the state and that kind of thing, and they try to make it affordable. Okay, but regardless of that, does it make sense of how I'm setting up? Is it clear that I'm not putting the year in my equation? Is it clear of where those CPI values are coming from? Are there any questions, comments, concerns, complaints, or criticisms about those problems? Find the equivalent price of a calculator in 1986 if you paid $15.89 in 2012. So here it's telling me the 2012 price, so 15.89. So I need the CPI value in 2012. And then we're looking for the 1986 price. So I'll need the CPI value for 1986. Okay. Well, I know that technology does not follow inflation uh like perfectly, because technology, often what happens is when something comes out, it's extremely expensive, and as time goes by, it plummets, and then it kind of levels off. That's typically what happens. And you can get a calculator now at the dollar store. I mean, that's, calculators are um, extremely inexpensive at this point in comparison to what they were. So I would expect, oh, and did I write 1986? Might have said 1985. I don't know. Let's just get those values. So 2012, 229594, 229594. And 1986, 109.6. Okay. Now, how do you actually solve for it? We're going to cross multiply, and then we're going to divide. So x equals 1584 times 109.6 divided by 229.594. And now I need to argue with my calculator. Okay. 15.84 times 109.6 divided by 229.594 be about $7.56 if it followed inflation perfectly, which it didn't. It would actually be more expensive. Is it 1589 or 1584? Well, that's a good question. 1589. Oh, I can't read my own handwriting. Thank you for saying that, because that's going to change my. Thank you. Yeah, that was a handwriting issue. 1589. 1589. And that's going to change my answer. Get rid of that. Thank you, thank you, thank you. E West. And can I change this? $7.59. Thank you, thank you, thank you. Okay, yeah, good call. Thank you for mentioning that. So what I did was I wrote 89 here, but handwriting and the tablet issue. And so when I copied it over here, it turned into a 4, and then that turned into a 4, and then that messed up my calculation. So I do appreciate you calling me out on that because that would have messed me up. All right. Hopefully it's clear how I'm setting it up. Hopefully it's clear that I'm not putting the year in the calculation because that wouldn't work. And hopefully it's clear where I'm getting these values. So again, where am I getting these values? I have a digital copy posted of the textbook. Section 4 is in Module 2, Learning Activities, but it's also in your textbook, either on page 41 or 42. Okay, so you have that as well. All right, now we're going to talk percentages, and then we'll talk about how we can interpret those. So let's clear page. There we go. Okay, this section introduces the idea of percentages, how to calculate with them. First, you will need to know how to convert percentages and decimals. A percentage has a percent symbol, so you know it is a percent. Otherwise, the number is classified as a decimal version of itself. Finish this chart. Convert the percentage to a decimal or decimal to percentage. So this is easy. We're just going to convert back and forth, and it's not going to get confusing until we get to the word problems, okay? But I'll show you the tips and tricks that I know to make this easy for us. And the first thing we want to do is we want to convert this 20% into a decimal. So one way, since I have the calculator up, I could do 20, and percent means per 100. So per 100 is 0.5, I'm sorry, 0.2. It's 1/5, but it's 0.2 there. Another way you can think of it is we just move the decimal place 2 times. So that's another way you can do it. But percent literally means per 100. Percent, 100 cents in a dollar, 100 years in a century, per cent. Okay, that's the idea. So here, if we move the decimal place 2 times to make it a decimal, you have 0.3378. Okay, just moving a decimal, or you can plug it in the calculator and divide by 100. That would do it. 300%, so the decimal is kind of here, and then you move it twice, you get 3.00, okay, as a decimal. 0.22%, well, you can plug that in your calculator and divide by 100 if you like, or you can move the decimal place twice. Okay, let me show you how to do that. Not just say it, I suppose. So that would be 0.22 divided by 100, and you get 0.0022. Okay, so that's how I'm getting that. I'm converting the percentage to a decimal. Okay, now this is going the other way, decimal to percentage. And since we're going the other way, we need to move that decimal the other way. So you can either move it to the right twice, making this 97%, or you can multiply this number by 100. That's the other way to do that, is you can go 0.97 times 100 and you get 97. That's telling you it's 97% per 100. If you took this over 100, you would get 0.97. So you can see that you can go either way. So here we can also move the decimal place twice to the right, and you get 67.88%, just moving that decimal twice. Here we can do the very same. We're still going to get a decimal, 347%. So what I did was I just moved it twice, or you can plug that in your calculator and multiply by 100. That's the other technique that we can do. 0.00347 times 100 gives us 0.347. There we go. And then 5, well, here's the decimal place. If I move it twice, what do I get? I get 500%. There you go. Right? So that is probably just review, but hopefully that review uh, is helpful, and now you remember what to do, just moving that decimal. Things I've noticed that tricks people up, if the percentage itself has a decimal, that can be tricky. That gets a little confusing. If you're over 100%, sometimes that's confusing. So like the decimal 5 is 500%. I see that get confused um, often. So watch out for that. But hopefully that conversion chart there helps you review of how to do that. Okay. Now, the other way is now we're going to actually use percentages to calculate certain things. And then we're going to um, do some word problems. And of course, that'll be the hardest level that we tackle is when we have to do the word problems. But there's really two methods of solving percent problems, and some people prefer setting up those proportions like we did at the beginning of class, and some people prefer to set up an algebraic equation. And what I'm going to do is I'm just going to show you both ways, and I'll let you decide which way you like the best because they are the same. They are the same. It's just what you prefer. So there are two ways to solve percent problems: by a proportion or using equations. I will only use equations for these examples. I can use proportions too. But you can use the other method if you like. See section 5 for more information on proportions. To find the base in the problem, use the phrase, the percent always acts on the base. The percentage will always be a decimal version using the equation method. A simple triangle of operations can be used to help with the percent problems. All problems can be written into the equation percentage times base equals the amount. So if they give you the percentage in the problem, then you can put this to the leftmost in your equation. The base is like the of value. When I say of, I mean the word of. Um, that that is the base, and then the amount is often the is in the sentence. If they use the is of phrasing, that's how you set it up. Now with proportions, you can set it up as is of percent 100%. Okay, the base is the of there, and so that's how you can set up the proportions. Of course, the notes say we're only going to do the equations, but I honestly think the proportions are easier, but you can use either method. It doesn't matter. You get the same answer. It's whatever you prefer. I find that students that learn the equation method in high school prefer that method. Students that either don't remember what they did in high school or are just starting from scratch seem to prefer the proportion. So maybe with fresh eyes, people tend to prefer the proportions for the setup part. But I'm going to let you choose because it's the same. It's the same. So we have the percentage of 24,000 is what number? So here is what? Is is the unknown. Is the unknown. And if you believe my nonsense up here, where I'm breaking down the English to the equation, the is the amount. So the amount is the unknown here. That's the x. So we're going to have percentage, and then the of is the base. So of this number, of is the base, of this number is what number. So, okay. Another thing I need to mention is that for the percentage, you need to convert this to a decimal when you actually use it. Okay, so I'll write a little note there. convert that to a decimal. So I need to convert this number to a decimal for my equation to actually use it. 0.000056 times 24,000 equals the amount. Okay, that's me trying to set up this equation exactly as it is. They gave me the percentage, but I need to convert it to a decimal when I actually use it in my calculator, in my calculations. This is the base. It says of 24,000. So that is the base. So that's the base. Is what number? The unknown is that X. And now we can finally calculate that number. So let us do that. And just in case you want to know where these extra two zeros came from, you have 0.0056 divide by 100. You see that we do get these extra zeros there. Okay, so I hope that helps. Um, why does it do that? Okay, times 24, 1, 2, 3. And so I think it's 1.344 is the amount. Okay, we didn't get a story for this. It's just that is the percentage. I'm not going to round right now because this is just an example. I'm not going to worry about rounding because we're just, at this moment, we're just worried about how you set this up. Okay. So with the equation, if they give you the percent, you have to convert it to a decimal. If they give it to you as a word problem, the base is the of part of base, and the is the amount. Okay. 200% of 17 is what number? Is what number is the x? Okay. 200% will be converted to 2 of 17 is what number? Okay. So I guess it's just 2 times 17. All right. Well, that's 20 plus 14. That's 34. So I guess x equals 34. 200% of 17 is 34. That's how I'm setting it up, right? But I have to convert that percentage to a decimal, right? 18 is what percent of 90? So not only are they giving me the information out of order, I'm also solving for something different. So I'm solving for what percentage? I'm solving for what is the percent? I don't know. I don't know what it is. So I have to solve for it. Of 90, that's the base because it says of. 18 is, that's the amount. That's the amount. Okay, so I can set this up just like I did before, but I just have to know what it is I'm solving for and what to do. So the percentage is what I'm solving for. So I'm going to put an X for my percent of 90. So times 90 equals 18. Okay, that's the idea there. So x times 90 equals 18. Now, how are you going to solve for it? We could divide both sides by 90. And that should do it. So x is 18 over 90. Let's go ahead and see what that is. 18 divided by 90 is 20%. Implies x equals 20%. Okay, maybe I should circle these two as they are my final answer. Okay. Does the equation method make sense? Is there any questions, comments, or concerns, anything whatsoever about how I set this up? Do you disagree? Is it right? Is it okay? Please let me know in the chat. If for any reason, I mean, sometimes I miswrite things. We know that's true. Sometimes I make arithmetic mistakes, but also sometimes I go too fast. So let me know. Tried to set that up. best I could, explain my thought process. Is of is a good way of working with that. But you know that of is always the base. Base is always what it's coming from. Base is always set up against 100%. Okay. But you can also set up the proportions as well. Okay. Keep bumping the microphone. Sorry. Okay. Let's keep going. We got a little bit more on this. So let's finish these problems and then we'll take our break. So if you paid $169.52 in income tax on a gross monthly income of 1,304, what is your income tax rate? Income tax rate is going to be a percentage. So it's really just asking, what's the percent? What's the percent? That's what it's really asking. First, identify the amount, base, and percentage. Here, the percentage is the unknown. The base is 1304 and the amount is 169.52. Okay, so then they're setting up their equation. Percentage times the base equals the amount. Then they're going to solve by dividing both sides by the base. Here they have, and they find that it's 13%. So that is the tax rate. Okay. Okay, so I hope it makes sense of the setup. That's the hardest thing about math is going from a story problem to what are we going to set up, right? Solving it is typically, not bad. If you knew what to do, it wouldn't be that bad. But that's the hard thing is figuring out what are you supposed to do. Okay, if you have $610 taken out in taxes each month, how much is your gross pay if you have a tax rate of 12.5%? Well, it seems like the percent was given to me, so I don't need to solve for that. And our equation before said percent times base equals amount. Okay, so I got to figure out which puzzle pieces do I have, and then I'll solve for the ones I don't have. I have $610 taken out in taxes each month, so I need to figure out, is that my base or is that the amount? That's what I need to figure out. How much is your gross pay? That's what I'm solving for. Gross pay. So I'm solving for gross pay. Is gross pay the base? Is that the total? Or is that the amount? Okay, well, I vote that the 610 is the amount taken out and that the gross pay is the total. This must be the base. That's what I think's going on. So from there, I can set this up. Okay, so it's 12.5%. So I need to convert that to a decimal when I actually use it. So 0.125 times my base, which happens to be what I'm solving for. So I can't plug that in yet because that's what I'm looking for. I know the amount taken out is $610. And so I need to solve for B. Well, how are you going to solve for B? You're going to divide both sides by that percentage. So this implies that the base equals $610 divided by 0.125. Okay, let me do that in the calculator. 610 divided by 0.125 is 4,880. So this is what I think the person is making a month. They're making about 4,880 and they're paying 12.5% in taxes, which is $610. This is their gross monthly income. Okay. Do you agree? Is the setup okay? Are there any questions, comments, concerns about how I do this? The hardest thing I think about math is looking at that story and setting up an equation. Setting up the equation is usually not too bad. The only thing here I did was divide. That's not too hard. I just plugged in my calculator and divided. That's easy. But setting up, that's everything. Sometimes copying down the problem is hard, but for me anyway. Hope it makes sense though. Please let me know in the chat if any questions, comments, or concerns. If a city has 1.55 million people and there are 1.054 million live in an apartment, what percent live in the apartment? Okay, well, this is very explicit of what I'm solving for. What is the percentage? I'm solving for the percentage. So again, I have percent times base equals amount. Okay. So I'm solving for percent. So I know the unknown is the percentage. It's got to be. All right. Now I have to figure out what's the base and what's the amount. If the city has 1.55 million people and 1.054 million live in an apartment, so what is the base and what is the amount? I think that this must be the base because it seems like it's the total amount of people. At least for my reading, that seems to be true. And for this value, this seems to be the amount of people that live in the apartment. Okay, so if I set this up, it's some percentage times 1.55 million equals 1.054 million. Now, I'm not actually going to convert this to scientific notation or anything like that. I don't need to. Since they're both in millions, it's going to reduce out. If you want, I can show you in the next step that that has to be true. But the percentage must equal 1.054. And if you want, we could even write million there over 1.55 million. And we see that that just cancels out. So we didn't even have to write it. Since they're both in the same unit there, it's going to cancel out, which is helpful to us. It makes it easier for us. Okay, so 1.054 divided by 1.55 gives me 0.68, but that must be 68% live in an apartment in this city. Okay. Does that sound, did I set it up correct? Is that okay? You agree? Disagree? Any confusion? Anything I can go over again? Just let me know in the chat um, if anything is confusing or you have a question. Out of 600,000 text messages a month, only 0.85% go to your uncle. How many texts are sent to your uncle? Okay. So, well, this is certainly the percent. So I don't have, there's no mystery of where this is coming from. So that's certainly the percent. Now, is this the base or is this the amount? And then how many texts sent to your uncle? Is that the amount or is that the base? So this is either, it's got to be one or the other. Okay, this is either the base or the amount, or this is either the base or the amount. I got to figure out which one it is. So it says out of. So I noticed the word of right there. That immediately tells me that this is the base. So just by that one word tells me that that has to be the amount. This is the amount sent to our uncle. Okay, so percent times base equals amount. Let's do it. Also recall that we do have to convert the percentage to a decimal to be able to use in our equation. Okay, we have to. 0.0085. That's the percentage converted to a decimal. And then we're going to multiply that out of all of the text messages sent that month. And then we're going to solve for that amount. Okay, so I just need to multiply. All right, so let us do that. 0.0085 times 600,000 text, and that's 5,100, which seems like a lot of text messages to your uncle, but that's what we found. Okay. Right. The last one is just I stole it from the book, and we don't really need to do that. So that one's okay. We can skip that one. All right, that is it for today. Or I'm sorry, that's it for this session. We still have another session to go through. One thing I want to pull together is note when there's only two operations we either do. We either divide or multiply. Here we divided. Here we divided. Here we multiplied. Okay. When are we dividing? When are we multiplying? So we are dividing when we're finding the base. We are dividing when we're finding the percentage, and we're multiplying when we find the amount. So there's only two operations you're going to do for these. You're either going to multiply or divide. You divide when you find the base, you divide when you find the percentage, and you multiply when you find the amount. Let's go up here and see if we can put that together. So up here, you're either going to divide or multiply. Well, in truth, I guess you did both. So CPI can't simplify it quite that much. Um, Also, for this, we technically both multiplied and divided. So I can't simplify it that much for those. But for the percentage times base, I can. So if you're solving for the base, you're going to divide. If you're solving for the percentage, you're going to divide. If you're solving for the amount, you're going to multiply. So I'll just write a little note that um, uh, in case you want to look back and make sure that clicks for you. Okay. Any questions before I clear the screen? I'm going to post these notes after class. Okay. We still have another session to go. We go to 11:50 today. But are there any questions over this? Comments, concerns? My in-class folks just went over proportions and CPI yesterday. And we had some arguments about cross multiplying in class. Hopefully it's okay for you. Okay. So I will post those notes after class, but then I'll post the notes that we're going to go over in a minute. Okay. Um, so I don't know if we'll go over the full time today, but we do have another session to go over. So we need to go over sections 6, and 6 is broken up into two halves. So we need to go over both of those halves, but I think now would be a good time for a break. I know I would like to get more coffee, so I'm going to take a 15-minute break. So I'm going to come back at 10:30 Bloomington time, and then I'm going to go over section 6 and answer any questions there might be. And also, I'll show you what homework is due for this week, okay? So I'm going to take a 15-minute break, get some more coffee, and come back and tackle this, okay? So uh, don't change that dial. So if you could in the chat, what is your favorite kids book? Thank you for posting those. What is your favorite kids book? Get set up here. Well, you must be able to hear me because you guys are responding, so that's good. I don't I won't know how the audio turned out until I listen to myself. I can't hear myself live, so hopefully it's working out. This is the first time I'm using this system, so tried to set it up earlier and it sounded okay, but you never know what's going to happen when you actually get into it. But you know us math teachers, we do like to mumble to ourselves, so you need a strong microphone to catch those mumbles sometimes. And I've noticed many times listening back that I thought I said something perfectly well and I was just muttering to myself. So that isn't helpful. And it's really bad in the classrooms. In the classrooms, they have, well, you wouldn't think it's bad. It's probably not bad um, for a certain type of teacher, but they have these audio bars. Like you might have an audio bar for your TV or maybe your family. I don't have an audio bar, but my family, um, a lot of my family members, they have these bars for their TV, and it's like that in the classroom. But there's a microphone in the ones they bought, and it works perfectly well if you're looking straight at the TV and if you're projecting very loud. But in like the middle of a problem, of course, you're kind of thinking out loud, and then the voice goes down, down, down. Or if you go to the computer instead of looking at the screen, if you go to the computer, then you can't really, it's just like muffled, and that's not so good. So hopefully, it was mentioned at one point that we were going to get little microphones, those little clip-on microphones, to help with that issue, but I think maybe it was just too technical for some of the teachers to deal with. So I think that's why we went with the sound bar. So I don't know. The person that really pays is the student, so it's probably you that has to pay that price. But um, yeah. Okay. Well, if you're back, make sure you wrote something. A lot of people did. Mother Goose, Where the Wild Things Go, Green Eggs and Ham, Love You Forever, Hungry Caterpillar, Treehouse, Magic Treehouse, Go Dog Go. Yeah. It's Scholastic Book Fair at my son's school. And of course, we had to get a bunch of books. And most of the books he chose have to do with Spider Man. So I think out of the 8 books we got, um, 4 of them were Spider Man. So he's very much into Spider Man and his friends. So my son's very much into Spider Man and his amazing friends with Miles and Ghost Spider. So I've been we're doing like, okay, we'll do one, every night it's like we'll do one Spider-Man book and then we'll do like a real book. Um, so been reading a lot of Spider-Man lately. Okay. Let me try to pull up the calculator. All right. So with section 6, it's split up into 2 parts. All right. If you look in the book, I think it isn't. I can't remember now. I don't think the table of contents, from memory, the table of contents doesn't actually show that it's split, but then the bottom of the page, it does show. It doesn't matter. But the homework is split, and that's good because it kind of focuses on one thing rather than everything at once. But um, it'll make sense when we get into it. So the first part is this descriptive statistics. And um, it's unless you're using a large amount of numbers, you can just use a regular old calculator, which is what we're going to do. If you have a huge amount of data, a huge amount of numbers, and when I say large, I mean you could go into hundreds of numbers that you're dealing with, or thousands or tens of thousands of numbers. And for that, you're going to want to use a spreadsheet program. Okay, we'll talk about how you could do that in that case. But for this, we're just going to figure out what these words mean, and we'll just use a standard calculator for that. Okay, so this is part one of section 6, which has to do with the statistics portion. All right, in this class, I mean, it's crazy. We're only in the second week, but it feels like we're already in section 6 now. But with section 6, what can I say? Well, I'll just get into it. But really, it's not going to be like the stats class that you took in high school. So if you took that in high school, you're more than prepared. If you haven't, don't worry, because in this class we really only introduce topics. We never really dive too deep. So we're just kind of like continually introducing topics. So don't be afraid. If you took stats in high school, it's not going to be that involved. So for the first part, what we want to find is the mean, median, and mode. And I suppose what we need to discuss is what those words mean. Get it? So that's the mean. And what does the mean mean? Well, you already know it as the word average. It means the exact same thing. So if you know what the word average means, you already know what the word mean means. Um, it's the same thing. And how you do it can be depending on the problem. But for this problem, what we would do is we would just add all of those numbers together and then divide by how many numbers we added. That's how you would get the average, and that's the same thing as the mean. The mean is the statistics way of saying it, as saying the average. So to find the mean, the only thing I'm going to do is just add these together. So I need to add these together first and then divide by how many numbers I have. Well, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. So when I find that sum, I need to also divide by, oops, plus 9 plus 10 plus 10. So that's 50. So I think it's 50 divided by 8 is the average, is the mean. So the mean is 6.25. Okay. So I'm going to erase this. I don't need the plus signs anymore. Now, these numbers they gave me, this data, is actually in order, and that's really nice. So they gave it to me in numerical order, and that's really helpful. But we see that, yeah, the average would be somewhere right here. It's somewhere between 5 and 7. Okay, so that's where the average is. I always think of scores in school because, well, the obvious, I'm always in school. So I always think of like, quiz scores and homework scores. So in this class, the average homework score was 6.25 if it was, let's say, 10 points. What can I say? The only other thing is we do have a duplicate number here and we still count it. So we still count it twice even though it was there. So to find the mean, we just add them all up, divide by how many we had. Here we have 8. So that's what we did. All right. What's the median? Well, the median is the middle number. It's the middle. Okay. Well, what's the middle number? I thought we just did that, right? Didn't you just say that the mean was 6.25? So what's the middle? This is a little bit more literal. So you need the numbers in order. They have to be in order for this to work. So they have to be in numerical order. And then you want to find literally the middle number. So what I'm going to do is I'm going to cross off 1 for 1 on both sides until I find the middle. Uh-oh. Because I have an even amount, I crossed off everybody. So then it is actually in between these two numbers. So the middle must be in between there. Okay. 1, 2, 3, 4. 1, 2, 3, 4. So I have 4 on each side. So the median is 5 plus 7 divided by 2. I have to take the average of those two numbers because I have an even amount of numbers. I hope that makes sense. Okay, well, what's 5 plus 7? That's 12. 12 over 2, you guessed it. It's the number 6. So you could have guessed that before, but that's what it is. So we've just determined, quantified it, if you will, that the number 6 is in between 5 and 7. That is the median. Okay. So we notice that the mean is larger than the median. Okay. So the mean is the average, the median is the middle. Okay. That means that this data is skewed to the right. That's what's going on. Okay. That's what's happening there. Now, what do we want to find? The mode. What is the mode? The mode is most occurring. It's the number that occurs the most. So what number occurs the most? 2, 3, 4, 5, 7, 9, 10, 10. There's only one duplicate. It must be 10. Okay. Sometimes there is no most occurring number, and sometimes it's a tie. Sometimes that happens too. If that happens, you have to write both, or you have to write the tie. So there could be two modes or two numbers for the mode. And then if there's no mode, you can just write no mode or nothing or NA, non-applicable. Okay. That's the idea. So it's fairly easy to do. You just have to know what it is you're being asked to do. So the numbers need to be in order to find the median. That's the most labor intensive, I think. The mean is just adding all the numbers and dividing by how many numbers you have. That's it. Okay. All right. So for example 2, I have this data set here I'm looking at, but I noticed that these are not in order. So to find the mean, I could just add them and divide by how many numbers I have. But to find the median, they have to be in order for me to find the middle. I can't find the middle any other way. So I'm going to rewrite this because I know I'm going to have to, so I might as well from the start. But I guess you could just do it for the median. So let's see. The smallest number I appear to have is 32, and I have 2 of them. So I'm going to cross those off just so I can keep track. What is the next smallest number? Looks like it's 51. And then 57, I think. And then 65. And then maybe 79. And then maybe 84. But we have 2 of them. And maybe 98. And did I miss something? Oh, I did. I said I had 2 84s, but then I didn't write it down. 98. Okay, now I think I have them in order. So now I'll be able to find the median, which is the middle number. Middle number. Okay. What's that mean? How do you find the mean? You add them all up, and then you divide by how many numbers you have. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So since we have an odd amount of numbers, we should have an actual perfect median. So 571. 571 divided by 9. There we go. 63.4 repeating. Okay. And then just to be sure that I didn't forget anything, this is a good way for me to check. I didn't forget anything when I rewrote them. They have to have the same sum. Oh, I did mess up somewhere. 32, 32, 57, 5, 7, 9, 84, 84, 98. Where did I mess up? Good thing I checked. 79. Oh, this was 21. There's no 21. Haha. Yeah, this is correct. 582. Yeah, so I made a mistake when I made a calculator mistake. I put 21 for some reason. Guess I got mixed up there. So this is correct. 582. You'd be shocked of how hard it is to do basic arithmetic when there's 20 people watching you. Okay, and then that's 9 people, so that's 64.6 repeating. So the mean is 64 point, and I'm just going to write point 0.6 repeating for my notes here. Okay, now what's the middle number? Well, since we have an odd amount, we should be able to actually find that middle number. And there it is. It's 65. So the median is 65. Okay. Now what's the mode? The mode is the most occurring number. What is the most occurring number? I believe it was a tie. We had 32s. We had 84s. Those are the numbers that occurred the most. So which one is it? I think it's both. Those are the most occurring numbers, so I'll write both. So you can have more than one mode, and you can not have a mode at all. Okay. But actually calculating it, especially when it's, when the data is smaller than, um, smaller than 10, a set of 10, it's not too bad. What I do notice is that the mean is less than the median. So that means that this has to be left skewed, which is what this next part's going to talk about. But that's the idea. Okay. So we'll come back to that. But let's see. I have some data here, and it is not in order at all. So let's put it in order. There's 12, and then I think 13 looks like the next. Are we going to skip all the way to 55? Looks like. Then 60. And then 65, I think. Get another 65. We get a 66. And then it looks like we're going to 71. And then from there, looks like we have 80, 90, 95. Okay, I think my data set is in order now. And so now I can find the middle number. Let's also find the mean. 12 plus 95 plus 65 plus 71 plus 13, 65, 66, 90, 80, 55, 60, 672. Now, if I put these in a different order, they better be the same sum. And they are. So that's a good indication that I didn't skip. Now, how many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think it's 61 point, we'll just say 09. Supposed to be 0. Okay, but what is the median? It's the middle number. And since we have an odd amount, we should have an actual middle number. And it looks like it's 65. Okay. Now, what is the mode? It's the most occurring number. What number occurred the most? 12, 13, 50, 60, 65 is a contender. 66, 71, 80, 90. I only see one number that repeated, so I think that's 65. So there's no contest there, just one mode. Okay. All right, now I noticed that with the mean, the mean is less than the median. The mean is less than the median. So the average is less than the middle, and that means that this is left skewed. Okay. That's what this is going to talk about. In some cases, data may be more prevalent in one area or another. When put into a chart, we can describe a graph in three special ways: right skewed, left skewed, symmetrical. A graph can also be none of those, of course. See section 6, part 1 for pictures in each type. But you can just determine from the mean and the median which case it is. So here we have the mean is less than the median. The mean is less than the median. And so this is also left skewed if you put them on a number line there. That's left skewed. Okay, what about this one? Here, the mean was greater than the median. And so that's right skewed. Okay, this is left skewed. This is left skewed. Right? If they're equal, they're symmetrical. If they're almost equal, they're almost symmetrical. But that's how you can determine left or right, is whether the mean is greater than or less than the median. Okay. Any questions about this first part here? Any questions, comments, or concerns? Maybe it's not a question. Maybe it's more of a comment. I don't, I've never met you, so I don't know, if you've seen this before, if it's obvious, or if it's beyond confusing. So I don't know. So let me know. Does it seem to make sense now? Okay. Sometimes it can be one of those where, well, it made sense in class, but then when I was on my own, it didn't make any more sense. That happens. Okay. So to find averages in Excel or any spreadsheet program, it doesn't have to be Excel, to find these in the spreadsheet programs, you can use these formulas, okay? So equals average. So let's say you have just a line, a column of numbers. You can write equals average, tell it to average that whole column, and it'll find the average for you. So that's really helpful when you have hundreds of numbers that you need to calculate, thousands of numbers to calculate, tens of thousands of numbers you have to average. You wouldn't want to do that by hand for sure. You wouldn't even want to enter it in the calculator, okay? But you can have the spreadsheet program average that. Same with median, same with mode. These are built in to be able to do that. Okay, so that can be quite helpful. Um, and I mentioned you wouldn't even want to type it into the calculator. Well, how do you do that? Uh, a lot of times, if you're if you're in the lab or something, you might have a piece of equipment that could record the numbers for you and output it as a file that could be read through your spreadsheet program. So I've done that. Sometimes in the laboratory, you might have something that actually outputs a file that you can manipulate in there. You might have you might be dealing with things from a website. You might be dealing things with a business. But if you can get what I'll call some clean data outputted, um, that you can manipulate it through the spreadsheet program as opposed to doing it by hand. Okay. If there's time, I will show that at the end of class. I don't want to open it now because it'll open another window. It'll be more confusing. But if there's time, I'll show that on my computer here. Okay. All right. So let's talk about part two. And part two is certainly related to this, but it just has um, a different kind of flavor to it. So, Section 6, Part 2 applies to the concept of average and a specific set of data with unequal importance. In other words, some numbers may count more than others. We call this a weighted average. It can be calculated in two ways by counting values or a percentage of weights. If a problem has many percentages, then it's a good indicator that that you are going to do a percentage method. Otherwise, you probably apply the counting method. So what does that mean? Well, here's the method of counting. You have the value times how many times it happened, the count, plus the value, whatever that is. A lot of times these are prices. So it might be the price times however many, like your grocery shopping, right? The value of the can of corn times how much the can of corn is going to cost. That kind of thing. And then divide by how many things you bought. That's the average cost of the items at the grocery store. Here, you might have a weight. So something might be worth 20% in this class, like an exam might be worth 20%. So what you would do is you would get the value, let's say the grade of the exam. So let's say you got a 92% on your exam. So that'd be 92% times that 20% of the weight. So this is a method of weighted, like a weighted grade book. That's very common at Ivy Tech and at most schools there to have that. So let's do some examples because that's really where this thing gets cleared up is when you actually look at um, some examples. Let's make sure it didn't clear that out for me. It didn't. So find the average price in a day if a local business sells 28 regular comic books at $16, 9 rare comic books at $30, and 2 mint collection comic books at $50. So here we're going to find that average price. And we don't need to know anything about comic books. This is just a question stolen from the book. But from there, we can find the average price that they're going to sell at this business. Okay. 28 regular at $16. So 28 times $16 plus we have 9 at the price of $30 and we have 2 at the price of $50 and then we're going to divide by how many things were sold. So that's 28 plus 9 plus 2. Okay, let's do it. All right. So that's 28 times 16 plus 9 times 30 plus 2 times 50 divided by 28 plus 9 plus 2. So I'm finding the average price for this day at this store is $20.97. So this is the value times count method. The value times count plus and so on over the count plus the count and so on. So that's the method we used. right? Hopefully it's clear how I did that. If it's not, write it in the chat. What is the average salary for a company if 18% of the employees make $36,000, 68% of employees make $44,000, and 14% of the employees make $64,000? Well, I'm going to guess this is probably the percentage method. Okay, so this is going to be that value times the percent plus, and then just, and so on. We're just going to keep going until we're out of data. So let's do it. 18%, I need to convert that to a decimal for my actual calculation, times $36,000 plus 68%. So I convert that to 0.68 times $44,000 plus 14% times $64,000. And we'll see what that average is. Since we were given as a percentage, we can see what that must be. Okay, 0.18 times 36,000 plus 0.68 times 44,000 plus 0.14 times 64,000. And I'm finding that the average salary for this company would be 45,360. Okay, but we can see it's not evenly distributed. 18% makes this. That's almost 20%. 68, 44, 14%, 64. So we find that the average is 45, which is just above this, which that makes sense. Okay. Hopefully it's clear where it's coming from. I hope. Now, this is like a weighted grade book. Okay, so what grade does this student get in the class? So we have their average test scores, their homework score is very high. Their average homework score is 100, and their average quiz score is 85%. The weight of the test for the whole class, all of their tests summed up are worth 60%. The homework is worth 20%, and the quizzes are worth 20%. And what does that add up to? 6 and 2 make 8 plus 2 is 10. So this is adding up to 100%. So that makes sense. All right. We want to see what is their score for the class. What did they get? What did they get? Okay. Well, how do you do that? You have the weight times the value, weight times the value, weight times the value, and then we're going to add that up. So let's do that. Okay. So I have 0.6 times 85, and that's 51. So I'm just going to write weight times, let's just do points. 51. Okay. Now, of course, 0.2 times 100, it's just 20. There we go. And 0.2 times 85 is 17. And we can add those up and find what their score is. So 51 plus 100 plus 17 is 100. Whoa. What's this guy doing? Plus 20. 51, 20, 17. That's better. 88%. So if they have the same grading scale that we do in our class, that would be a B. Okay, so they would get letter grade B if they have the same, but they get an 88% in the class. Okay, so how do you do it? You take the weight times the average test scores, the weight of the homework times the average homework score, the quiz weight times the average quiz score. That's how you do it. Okay, hopefully that's clear. I hope. All right. Now, number 7, calculate the GPA for a student with the following grades. Ivy Tech uses a general grading scale for all problems such that A equals 4, B equals 3, C equals 2, D equals 1, F equals 0. And that is what Ivy Tech uses. That's what's on your transcript, which I think is nice because, again, if you go to IU, um, you know, you can get something, you can get like a 92% in the class, and that's A minus, and it's basically a B. Um, they don't give you the A, the full A. So that's very disappointing that they do that. Or I can say I was disappointed when I would get those A minuses. I didn't like that so much. I find that frustrating. But here, you really only need to get a 90, to get the A, and you get the full point. So that's good. So we're going to find the GPA. So let's do that. So we have credits, which is kind of like the weight in a way. And then we have grade, but we're going to have to convert that to how much points they get. So let's do that now. So for the B, that's a 3. For the D, they only get 1. For the A, that's a 4. A is 4, and C is 2. So I'm going to convert those to uh, their decimal representation, since that's the scale we use at the school. The credits times the grade is how many points we get for the GPA. So we're going to multiply that. 3 and 3. 3 times 3 is 9. 5 times 1 is 5. 2 times 4 is 8. 1 times 4 is 4. And 3 times 2 is 6. Okay. If we sum these up, that's what we need to do. We need to sum them up, but then we need to divide by how many credits they took. Okay. So let's do that. 9 and 5 and 8 and 4 and 6 give me 32. So GPA is going to be my points divided by my credits. And so my points here, I got 32. For some reason, I wrote 33. £32, but how many credits did we take? 3 and 5 and 2 and 1 and 3 is 14 credit hours. So we have 32 divided by 14, and that gives us a 2.29 GPA. So, kind of like a C, but this is our GPA for this student. All right. Is it clear how I did it? Do you agree? Disagree? Questions, comments, concerns on the GPA or the weighted grade book that we just did? Any questions about that? Questions, comments, concerns?
Where did you get the 14 from?
I was adding these up. So I added up the credits.
Okay.
Yeah. So I think this is 14. Yeah, 14. Okay. 14 goes there. Points, I had to multiply these product to get those. Okay, that's how you get GPA. Let's keep going. Consider the grades below. What will the final class grade for the student? The midterm is worth 25%, the final is worth 30%, the homework is worth 15%, quizzes are worth 15%, and the group work is worth 15%. Okay, looks like we have the midterm, the final, the homework scores, quiz scores, and the group work. What they did not do is they did not give us the average. So that's on us to find it. We're going to have to find those averages. Then we're going to have to deal with the weights. Then we're going to have to find that final grade. Okay, so let's do that. So I'm going to find the average. I'll just copy this down. There's only one score, so there's nothing to be done there. Just copy that down. All right, for this, I need to calculate it. So I have 100, a 90, a 92, a 92. And that's over 4 scores. So 374 divided by 4 is a 93.5. Okay. That's the average homework score for the student. An 80, 85, a 0, 78, 243 divided by 4, of course. 243 divided by 4 is 60.75. Okay. And then the group work, 90 plus 94 divided by 2, 92. Now we have their average scores, and they told me the weights. So I'm going to write that down. The weight for the midterm is 25%. The final is 30%. The homework was worth 15%. The quizzes are worth 15%. The group work was worth 15%. Okay? Now I should be able to go average times the weight gives me the points, and then I'll add all those up. So I'm going to need to multiply these. Okay? Or I could just do it all in one step. In fact, that might be easier. But I would multiply these. I think I'm just going to do it in one step because it would be a lot easier for me just to do it once than everything individually. So 82 times 0.25 plus 78 times zero point 0.3 plus 93.5 times 0.15 plus 60.75 times 0.15 plus 92 times 0.15. And I'm getting an 80.84. So I would say roughly 81%. Okay, would be their final course grade. All right. Any questions, comments, or concerns about that one? Okay. What is the average grade for this semester? Class size, class average is given below. So the class size, and then this was the class average grade. Class size, class average grade, class size, class average grade, class size, class average grade. We want to find the average of all these classes. How do you do that? Well, a few different ways. What we could do, we almost could do two different ways. I think the best way would just be to kind of do what we did with the comic books. I think that's going to be the best way for this question. So let's do that. 18 times, oops, 85.2 plus 21 times 90.1 plus 17 times 82 plus 12 times 67.8 divided by how many people we have? 18, 21, 17, 12. Okay, so I got to figure that. What is the average course grade with all of these folks? Okay, so let's do that. 18 times 85.2 plus 21 times 90.1 plus 17 times 82 plus 12 times 67.8. Then we need to divide by that sum, 18, 21, 17, 12. And I'm getting the average course grade was 82.8. Yeah, 82.8. So I used the count method on this one because they gave me the class size. So that would be the count method. This was, of course, the percent method. GPA is kind of like its own, really its own flavor here. You definitely need to know GPA. So certainly master that. It's on the homework, of course. So get that. And then course grades in this way. Weighted grade book, also important. So I'll just put weight grade. An important example. Definitely going to be on that exam when we get to it. Okay, we'll talk about the exam next time. Count method, yeah, it's important, but these I can promise you GPA and weight. Certainly you'll see it again. Okay. Okay. So that's that. Any questions before I exit out of this screen? I'll post these notes after class, promise. Promise, 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 as well as this recorded video. Okay. So the next thing I want to do is I want to show Excel or a spreadsheet program and how that works. And I'm also this is the perfect time for me to introduce uh, the um, the project. So the project isn't due for a while, but I might as well introduce it because it covers these topics. And I need to use Excel to do it. So I think now would be a good time to show that. Okay. But I have to pull it up. So bear with me for a moment. And I'm going to pull up different things on my laptop. So I'm going to pull up this project. And the reason I'm going to pull up the project is because it's a perfect example of using Excel or a spreadsheet program to calculate these grades. So in the project, it's a weighted grade book. So we see this right here. You can see my ugly face. I already have a recorded video of me doing this, but we're here live, so let's look at it. Here's somebody's grades, and we can calculate their grades using a spreadsheet program. So that's what I'm going to do now, or I'm going to attempt to do. Okay, so I'm going to pull up a blank spreadsheet. I'm hoping it's projecting that on your side. And the ugly thing is I'm just going to have to type it in myself, but that's okay. Let me make that a little bigger. Exam 1, Exam 2, Exam 3, review, project, quiz, homework. Okay. Now, one of the common questions I get for the project is how do you get the numbers in your spreadsheet program? And I'm hoping you can see that I am typing them in. I guess you can't see my hands, but I'm typing them in. That's how I got them in there. So I'm just typing in those values and making my best effort to not make a mistake. 38, 0. Okay. And then homework scores are broke up into two two rows there, but really it's just one category. So 60, 62, 70, 82, 90, 80, 0, 55, 68, 52, 0, 62, 65, 50, 20, 0, 38. Okay. So it's obviously stretched out, but there are the values that are posted in the project. Now I need the weights. So what are the weights? The weights are given here. So I need to enter those in my spreadsheet program. Maybe I can move this over a little bit. And enter those in. Okay. Weights. Right. So the weight is exam 1, exam 2, exam 3, review, project, quiz, homework. What are those weights? 20%. I'm going to enter in the percentage symbol. So when I do my calculation, I will have that right. 10%, 10%, 10%. There we go. Okay. So I have the students. Whoops. Hit the wrong button, get the wrong thing. Okay, I think we're okay. So I have the students' scores and I have the weights plugged in. Now I think I can actually find their final grade just doing that, right? What am I missing? I'm missing the averages. So when we did this by hand, I had to do the average. So I'll let you decide when you come to this of how you want to do the averages, but um, you can either calculate it in a separate step or when you calculate the final grade, you can also just enter this in. So there is such a thing as an average button in the program. So if I hit equal sign and then type average, it will average them for me. Okay, so I can do that in this program. It will find the averages. Let's do the homework scores. Let's find the averages. So I'm going to write average there. And then I'm going to say equal sign, which tells the program I want you to wake up and I want you to calculate this for me. So I want you to calculate these values. And what I can do, sorry for the flipping, is if I want, I can highlight the values that I want it to average. Okay. And I can hit enter and it averaged them for me. All right. If I double click, you can see what it's doing. It's taking the values from B7 to U7 and it's finding the average for me. I didn't have to do that by hand. And for the project, I don't want you to do it by hand. I want you to use um, Excel. Okay. So for the average here, okay, what do we need to do? We need to find the average of, sorry for the flipping. We need to find the average quiz scores. Okay. So again, sorry for the flipping, but it's hard to project on Zoom. So I'm going to highlight what are the average quiz scores. Whoops. What are those average quiz scores? So there they are. They're 58. Okay, great. Now, what is the average here? So I'm going to write average so I remember what this number is I'm actually calculating. Equals average. And this is the average project. So, yeah, 85. That makes sense. 90 and 80. Okay, looks good. Average. Now, what is the average of this? We have review, 3 scores. Here we go. We can choose how that rounds. We can choose how it rounds if we want. If we want to change it, you can press this button and it'll change it. Press that button and it should change it. Let's just go to the 100th. That should be fine for our purposes. Yeah. Yep, that's fine. And if we want, we can go to the 100th. There we go. That way they're all the same. And let's do the average of this category equals average. And oh, those are just going to be those values. So that's very easy. Average equals average. And here we go. Average, whoops, equals average. There we go. All right. So those are the averages of those categories. Great. So we have that in this column, all the average of the different categories. So when we want to find that final grade, we know what to do. We know we have to multiply the weight times the average score. That's what we did. And then we want to add those all up. So that's what we're going to do. I've had different students do it in different ways. So sometimes what they'll do is they'll do yet another step where they'll do the weight times the average, and they'll do it in this step. Okay, that's probably really hard to see in your screen because it's so stretched out, but that's the idea, is that you could break this up into steps if you want, or you could do it all in one step. The problem with all in one step is if you make one mistake, it's hard to fix, but that's it. So you could do the weight times the average, and that would equal the points. Okay, so we could do that. So equal sign. I want the average score here times the weight, the weight there. And so that's how many points they get there. Okay, so 72 is the average. Here we go. Okay, equals average times the weight. There's the points. Average times the review equals average times weight equals average times the weight equals average times the weight. Okay. Now, what's their final grade? The final grade is the sum, whoops, is the sum of this column. So I just need to add this all up. I just need to add this all up. So I'm just going to hit equals. It turns out there's a sum button or a sum function if you want to use that, or you can just add them all up. You can just say add this, add this, add this. I'll show it both ways. So you can add these up, and there it is. Okay, so that's the final grade using this method. All right, if we want, we can change the rounding. All right, there it is. Just to show you that that is the same, final grade equals, and then I can just go plus this, plus this, plus this, plus, plus, plus. Get the same score. Okay, nice. All right, so that can be done as well. And in fact, you can do that all in one step if you're careful. So you can just do it all at once. So you could go exam 1 score times the weight plus exam 2 score times the weight plus exam 3 score times the weight plus And then, this is our first time where we're in trouble because we have 3 scores here, and we want to times that by the weight. So this is the first time where we have to do it some in the other way. What I can do is I can still do average. I can have it average those scores, close parentheses, and multiply times its weight. Whoops, times its weight. There it is. So you can do this all in one step still, and this is a lot in a very short amount of time, but it's being recorded, and I know that, so that's good. The great thing is that um, you're going to get these skills, and I think this is one of the most beneficial things you will get out of taking this class if you've never used a spreadsheet program before, is attaining these skills, because you can't believe how many times it comes up. Once you know you can do it, how many times it would be helpful. So I should get that same score, and I did. So you can do it a few different ways just off the top of my head. All right. But it needs to be done. It needs to be done in a spreadsheet program. And it needs to be what we call a live spreadsheet. Okay. What does that mean? Well, it means that if I change any values, so if I change the project score here to an 89, that final score changes. These all change because it's a live cell and everything is connected to each other. So I can go back. So I could go, oh, you didn't get a 62 on that homework. What you got was a 75, and you can see how it changes the final score, changes that final score. So that's what we need, a live there. You can't just write the answer. You have to really, really do it. But you saw it here once. There's 2 other videos there posted, and this video will be posted later today. So that's a good start. 78, change that, changes this final score. What if they didn't get a 58 on their first exam? What if they got 100? Well, that'd take them up to a 75 there. All right. The really tricky thing that is not expected is if you wanted to do some kind of conditional statement to output a letter grade. That is very involved just to put the letter grade. So if you want, you can just write the letter D for this, and that would be good enough. You don't have to write the conditional statement that makes it happen. It's quite involved just to make the letter, so it's not expected. But that's a preview, and I think I was able to do that whole thing. Um, I don't know, in a matter of like a few minutes. It wasn't too long I did that, but you have this recording. There's 2 other recordings. That's the project, so you have to make that happen. And then also, let me share my screen again. Go back to the project. You will have to read through the actual instructions because there's many questions you have to answer, which we'll talk about next time. But I think it would be good if you could to get at least that Excel going. At least you never need to buy software for this class. Excel is part of your tuition. You get access to it. It's on all the school's computers, and then also you can use it with your school ID if it's asking you to do that. And then you can also use the online version of Excel with My Ivy. So look in My Ivy, and you'll see there's an Office 365 link, or you can use the school's computers. That's fine. You can use other spreadsheet programs, but if you do so, you just need to make sure that you're outputting a file that I can read, because the computer doesn't read it. I have to do it on my computer. Okay, there's 2 other videos of me doing the same thing, and we'll talk more about the project now, or we'll talk more about it later. But I just wanted to introduce it since we just talked about those um, grade books, and that's where it's coming from. So, any questions, comments, or concerns about any of that? Okay, well, let's see what you do have to do this week. Let's look at the calendar. And you don't care about my other classes, so let's not focus on that. So we have two homework assignments that were due today. You had homework section 3 and quiz 1. Okay. If you haven't done it, you need to get those done, right? Get those done. They should still be open for partial credit if you didn't get that done. Friday, you have homework section 4, homework section 5. Again, this is a week class, so it's twice as fast. So that would be a week's worth of homework, but now it's only a few days for you. That's the first part of class. And then going forward, you have section 6, part 1, section 6, part 2, and quiz 2, which covers 4 through 6. You have 30 minutes to complete it, and you're allowed 2 attempts. You can use your calculator. Yeah. If you have any questions or concerns about any of the homework, if any questions come up you don't understand, let me know. Please recall that you do need to use those values in the textbook for section 4, the CPI. If it talks about, was it section 4 or section 5 now? Now I'm all twisted up. It says page 41. Let's see. Right here. In 1988, a certain model of a car cost $17,000. What would it cost in 2017? You need to use those values that we talked about. So I have a digital copy posted in the module. So you can use that from section 4 if you want. I think it was page 7 on the PDF. It's page 41 or 42 in your textbook, depending on which edition you're looking at. So you have access to those values, but you need those values to be able to complete the homework. Okay. 2009 average selling LCD was 700. What would it cost in 2016? Okay. So you'll need to use those CPI values. 2013, the most expensive cocktail made with cognac was sold for 12,000. What would be the equivalent in 2014? So you're going from 13 to 14. Have to use those values. 93 and 87. Yeah, you're going to have to. So that's where those values are coming from. So please refer to those. Again, they're in the module here for the Domino's Pizza, the very same. Let me pull it up one more time just to remind you, if you don't have a textbook, or maybe you just prefer, I mean, you're in a virtual class, maybe you prefer doing the virtual realm. It's in this module right here. And I think it was page 7. There it is. Those are those values, that table you need. Okay. All right. That's what you got to do this week. All right. So I saw there was a question about the exam. We're going to talk about the exam next time, which covers sections 1 through 6. But if you're interested now, we can talk about it. So the exam is going to have a test review. So you'll have, that's kind of like your, I mean, it's graded, so you have to do it. But the test review is kind of like a pre-test. So you'll have that academic honest policy, which you have to agree to before you take the test. And then exam 1, which will be due February 2nd, it's really just like a big quiz. So it's very similar to your homework and your quizzes. It's written out the same way. It's just answering questions. So it's like a mega quiz. Huge. It's just a big quiz. And then the only thing that's different is you're going to upload pictures of your work. So you're going to upload your partial credit. I think I have a short video. If it loads, I have a short video of examples of how you can upload that. But that can be really helpful for me to give partial credit. So that would be the only thing different about the exam than the quiz. Is the quiz, there's no, you're either right or wrong or that kind of thing. But the exam, it's worth so much. Try to give some partial credit for everyone for every question. And as we all know, there's always rounding issues and that kind of thing. So that's where the partial credit pictures can really help. Um, yeah, Mackenzie said all classes are different, and you got that right. Because my other 123 class in person, we're going to meet at 3 o'clock today. Totally different system. So they're going to take their test on paper. So it's in class, it's on paper. It's different. It's just different. Um, they don't get to use their notes. You do get to use your notes. So that's different too. Um, you're going to take it on your own time. They're going to take it on my time, that kind of thing. So that's quite a bit different as well. So it's different. What I find is, in the end, for whatever reason, scores tend to average out about the same. Um, it's pretty weird how that works out, but in the end, it is about the same. So we'll talk more about the exam next time. But that's the idea. Okay. I want to keep it as easy going as possible. I can for a 100 level college level math course. You know, you're not a math major. I understand that. I do hope you get something out of the class. I think Excel, if you haven't used Excel before, it'll be a prime candidate of something you will come away with after this class as having that skill. Um, but it's possible you already use Excel at your job or something. So, and I know many places use Excel for scheduling and that kind of thing. Maybe you do. Maybe you're the one that sets the schedule. I don't know. And we won't even, talk about tip of the iceberg. I mean, we're just going to touch on what Excel can do. It can do more things than even I know. And one thing that's not required that I do know is you can set a conditional statement for if this value is between these numbers, you can have it set to give you the letter grade. I think on one of those videos I actually do it, but it's not required, but it can be done. You just have to set it up. Yeah. So that's this week, which is a lot. I know it's twice as fast. But next week we will talk about the exam, talk more about the project, and yeah, we'll probably talk about section 7 as well. All right, so I'm going to stick around for any questions there may be. If you have any questions on your homework or quiz or anything like that, don't hesitate to send me a message and I'll get back to you as soon as I can. Until then, I'll see you next Tuesday.